All right, in 5.2, we're going to take a look at right triangle trig. So, the first place we're going to look is the six trig ratios. You've definitely seen at least three of these before in geometry. And if you took pre-calc last year, you've seen all six. Okay? But the three you have certainly seen before are sine, cosine, and tangent. Okay? And just to refresh your memory, sine is defined as the opposite side over the hypotenuse of an angle in a right triangle. So in this example here, for this right triangle, we're saying that with respect to theta, this side, side A, is the opposite side. Side C is the hypotenuse, that's the side that is opposite the right angle. And then B is what we call the adjacent side. So sine is defined as opposite over hypotenuse. Cosine is defined as adjacent over hypotenuse. And tangent is defined as opposite over adjacent. Remember, the shortcut, or the little memory tool for that, was SOHCAHTOA. Right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right. We're going to introduce three more trig functions in this section: cosecant, secant, and cotangent. All right. Cosecant, and let me actually write out the entire function here. So CSC is an abbreviation for cosecant. SEC is an abbreviation for secant, and COT is an abbreviation for cotangent. All right, so cosecant is defined as the hypotenuse over the opposite side of an angle. Secant is defined as the hypotenuse over the adjacent side, and cotangent is defined as the adjacent over the opposite. Now, notice that sine and cosecant are exact reciprocals of each other. This is opposite over hypotenuse. This is hypotenuse over opposite. The same is true of cosine and secant, and of tangent and cotangent. Okay, sine and cosecant are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. One way to remember which ones go with what's the reciprocal of what, is that each pair has a co. Okay, each pair has a co. So sine is paired with cosecant. Secant is paired with cosine, and tangent is paired with cotangent. Right? That's how we're going to remember which ones are the reciprocals of the other ones. Okay? Now, I do also want to point out here that it does matter which angle that we are looking at in a right triangle. So for all of these examples, saying that sine is A over C, opposite over hypotenuse, only applies to this angle. So if we were to, let's say, make this angle alpha up here, then with respect to this angle, this would be the opposite side. This would still be the hypotenuse, but this would then be the adjacent side. Okay, remember, adjacent just means right next to. So then the sine of alpha would be B over C. The cosine of alpha would be A over C. So do make sure that you are looking at the correct angle in a right triangle whenever we're talking about these trig ratios. Okay? And we're going to talk a lot about these trig ratios as we go through this course. So first, let's look at an example where we are just listing the six trig ratios for theta here. Well, in order to do that, we need to know all three sides. I'm missing a side here. Whenever we're missing a side, we can use the Pythagorean theorem to solve. So I can say a squared plus b squared equals c squared. The legs are a and b. It doesn't matter which one's which. So we'll say 3 squared plus the square root of 7 squared equals c squared. Then 3 squared is 9. The square root of 7 squared would just be 7. 9 plus 7 is 16. Take the square root, and we will get that c is equal to 4. Again, when we take the square root, we would usually end up with positive and negative values, but since we're talking about a length, we would only include the positive root. So this side has a length of 4. Now, with respect to this angle, let's label the sides. So with respect to this angle, this would be the opposite side, this would be the adjacent side, and this would be the hypotenuse. So sine of theta will be opposite over hypotenuse. So that would be 3 over 4. Cosine of theta would be adjacent over hypotenuse, which would be the square root of 7 over 4. And tangent of theta would be opposite over adjacent. So 3 over the square root of 7. Now, whenever we end up with a square root in a denominator, we do want to rationalize. So we would want to multiply top and bottom here by the square root of 7. And we would just end up then with 3 square root of 7 over 7. Now we want to list the other 3. Right? We want to list the cosecant of theta, the secant of theta, and the cotangent of theta. Now I intentionally listed them in this order because I know that cosecant is just the reciprocal of sine. So if sine of theta is 3 over 4, cosecant of theta is 4 over 3. If cosine of theta is square root of 7 over 4, then the secant of theta is 4 over the square root of 7. Now again, we have a square root in the denominator here, so we need to rationalize. So times square root of 7 over square root of 7, and we will end up with 4 square root of 7 over 7. Then cotangent is the reciprocal of tangent. Now, I actually have 2 versions here. We can be a little smart with which one we choose to take the reciprocal of. I'm going to take the reciprocal of this first version because that will lead to not having a square root in the denominator. I won't have to simplify anything then. Okay, so these are my 6 trig ratios for this specific right triangle. Okay, so now let's take a look at our special right triangles, our 45, 45, 90, and our 30, 60, 90. And let's list out all 6 trig ratios for those 3 angles, for 30, 45, and 60. Okay, so now in this table, I've got 30 degrees is the same as pi over 6. Okay, so if we just pick out one of my 45-degree angles and label, right, with respect to that, this would be opposite, adjacent, and hypotenuse. So if I start to list out the sine, well, the sine would be 1 over the square root of 2. So before I put that in the table, let me come off to the side here and rationalize that. Right? Opposite over hypotenuse would be 1 over the square root of 2. But I would need to rationalize, so times square root of 2 over square root of 2. So we would just end up with square root of 2 over 2. So that is my sine of 45. Then cosine would be adjacent over hypotenuse. That's actually the same, right? 1 over the square root of 2 would rationalize to the square root of 2 over 2. Then tangent, opposite over adjacent would be 1 over 1, would just be 1. And then cosecant is going to be the reciprocal of sine, right? So we said that that was 1 over the square root of 2. So the reciprocal of that would be the square root of 2 over 1. Same with secant. And then cotangent is the reciprocal of tangent. The reciprocal of 1 is just 1. So let's come over here then and do the same with 30 and 60. So with respect to 30 degrees, this is the opposite side, adjacent, and hypotenuse. So the sine, opposite over hypotenuse, would just be 1/2. The cosine, adjacent over hypotenuse, square root of 3 over 2. And the tangent, opposite over adjacent, well, that would be 1 over the square root of 3. So rationalizing that, multiply both the numerator and denominator by square root of 3 would get me the square root of 3 over 3. Then the cosecant is the reciprocal of sine, so that would be 2 over 1. Secant would be the reciprocal of cosine, so that would be 2 over the square root of 3. Rationalize this, multiply the top and bottom by the square root of 3, and we'll get 2 radical 3 over 3. And then finally, the cotangent would be the reciprocal of tangent. Well, we said that was originally 1 over the square root of 3, so the reciprocal of that would just be the square root of 3 over 1. Now, finally, let's take a look at 60 degrees. So with respect to the 60-degree angle, this is now the opposite. This is the adjacent, and the 2 is still the hypotenuse. So with respect to the 60-degree angle, opposite over hypotenuse, sine would be square root of 3 over 2. Cosine, adjacent over hypotenuse, 1/2. Tangent, opposite over adjacent, would be the square root of 3 over 1. Cosecant then is the reciprocal of sine, so that would be 2 over the square root of 3. We already rationalized that, and that would just be 2 radical 3 over 3. Secant is the reciprocal of cosine, so that would be 2 over 1. And cotangent is the reciprocal of tangent, and we already rationalized 1 over the square root of 3 to be the square root of 3 over 3. So these trig functions we're going to work with a lot, okay? Especially in the next section when we start looking at the unit circle. Okay? So this is going to be an important chart that we have created here. So let's now take a look at our reciprocal and quotient identities. So the reciprocal identities here are really the same as what we said up here, right? We said sine and cosecant. If I just flip them, okay, they're reciprocals of each other. That's just saying the same thing here. Sine is the same as 1 over cosecant. Cosecant is the same as 1 over sine. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. Okay, the quotient identities then are also going to be pretty important. Tangent, we can actually say, is equal to sine over cosine, and cotangent is equal to cosine over sine. Okay, let me real quick show you why this one is true. Okay, so if we go back to, let's say, this triangle here, right, let me clean this up a little bit. And let's just look at theta. Right, so we said that the sine of theta was equal to A over C. So let me put sine over cosine. Sine of theta over cosine of theta. So sine of theta is A over C, and cosine of theta is B over C. Well, whenever I'm dividing a fraction by a fraction, that's the same as saying A over C times C over B, right? Dividing by a fraction is the same as multiplying by the reciprocal. The c's would cancel then, and this would just equal a over b. So sine over cosine equals a over b. That's exactly the same thing that tangent equals. Okay, so that's where this quotient identity comes from. Tangent is equal to sine over cosine. And then cotangent is derived exactly the same way. Right? Cotangent is just the reciprocal, so we can say cotangent is the same as cosine over sine. Okay, so let's use our reciprocal identities here to figure out the rest of the trig functions given this. Right? So let's say I know that sine is 5 over 13 and cosine of some angle is 12 over 13. Okay, well, first, let's use the idea that we just talked about, tangent. Well, tangent is the same as sine over cosine. So sine of theta over cosine of theta. So sine is 5 over 13. Cosine is 12 over 13. So this would just be the same as 5 over 13 times 13 over 12. The 13s would cancel, and this would just be 5 over 12. So now I can easily write the other three. Right? Sine is the reciprocal of cosecant. So the reciprocal of 5 over 13 is 13 over 5. Secant is the reciprocal of cosine. So that would be 13 over 12. And cotangent is the reciprocal of tangent. So that would be 12 over 5. Okay. One other small thing I want to mention, make sure that you are including the angle whenever you're writing your trig functions. Don't just write sine equals 5 over 13. Make sure that you're writing sine of theta or sine of alpha, whatever the variable is, whatever the angle is. Make sure you're including that here. Right? Our final example is if we're just given one of the trig functions, one trig value. We want to find the other 5. To do that, we are going to have to draw a triangle. So, let me draw a right triangle here. And so now, let's put our theta here. Sine means opposite over hypotenuse. So this piece of information actually gives me two sides of the triangle. The opposite side from theta is 2. The hypotenuse is 5. We just need to find this missing side here, and then we can list our 6 trig functions. So we'll set up Pythagorean theorem. A squared plus b squared equals c squared. So 2 and my unknown are the 2 legs. The hypotenuse is always c in the Pythagorean theorem. So 4 plus x squared equals 25. Subtract the 4 over, we get x squared equals 21. Take the square root, and we would just have the square root of 21. If this were to simplify, we would want to make sure to simplify this. Okay, if I could bring something out, I didn't simplify, make sure to do that. And again, we only take the positive root here. So I now have all 3 sides for my right triangle. Now I can list my 6 trig functions. So the sine of theta, opposite over hypotenuse, 2 over 5. We were already given that one, but I just like to get in the habit of listing all 6 anyway, even if we're given 1 or 2 of them. Cosine then is adjacent over hypotenuse. I should also mention that even if we do end up with a square root here, we want to keep that value. Right? We want to leave that as an exact value. Don't get a decimal approximation for that. All right. Then tangent of theta would be opposite over adjacent. So 2 over the square root of 21. We need to rationalize, so multiply by the square root of 21 over the square root of 21, and we'll get 2 radical 21 over 21. Then my other 3 are just the reciprocals, so cosecant is going to be 5 over 2. Secant is going to be 5 over the square root of 21, which we need to rationalize. So multiply top and bottom by the square root of 21. And we'll just end up with 5 square root of 21 over 21. And finally, cotangent. Let's take the reciprocal of this first version so we don't have to do any more work. We get the square root of 21 over 2. All right. So that is it for this video. The final question is going to pop up asking you what questions you have.